Welcome to the second part of the MFRM blockchain technology module. In this part of the lecture, we're going to drill down on some of the technical issues of blockchain technology. Just as a quick recap from last time, so the feature of a blockchain is it is essentially best thought of as a worldwide distributed database, which is peer-to-peer, which does not require trusted third parties, which is censorship resistant, meaning that you can't change past records unless you have permission explicitly from a user. It is secure, and that's very critical. It's fully decentralized. Now, the key questions that arise and that we want to answer in this set of slides is we want to understand what are the properties of the records that are kept in this database, and how does the updating protocol work for record changes, and what are the challenges that come with the distributed nature of the protocol and the peer-to-peer part of it. So let's just give you a very quick recap again of the process of how the blockchain works. You have a person here who wants to do a transaction, so she signs a contract. She digitally signs it with a signature, so she gives the authorization to make a change in the network. She then sends that transaction to a network. The network goes on and verifies that indeed this person is the owner or has the authority to make that change. If she does that, if it has been authorized, then it gets into a pool of authorized and validated transactions. And now there's a process which has to be, we have to decide which of these transactions will be and in what order they will be put into the database. The mechanism is there that is used is the so-called proof of work. This is what we spend most of our time on, where a group of entities called miners race to find a solution to a math problem. What that does essentially creates a random mechanism to determine who is the one who gets to determine what the next round is. There will be a winner of this group. Now, what that person or what that entity can do is it could then form a block, put the records together, and form, put these transactions into the database, and thereby form a new block. And the entity gets rewarded for that. And what I have not put in here, which is sort of happening in the background, there is also a broadcasting of that new block, and then there's a consensus among the network that this new block will be entering the blockchain. So just very briefly of the workflow, just again, so the transaction is signed, it's sent to a peer-to-peer network of validators. They validate that indeed this is a properly signed transactions, and then they're bundled to be put into a block. This is, by the way, just a recap of the last lecture. So the critical part is the architecture of a block, and some of these items that are in this block we want to now discuss. So a block is a little bit like, when you have a LaTeX or a computer program, you have a header where you load some pieces of information, and then under the header comes the main part, which is the meaty piece that you're really interested in. So the header has a few critical components. It has a link to the past block, which essentially creates the chain. It has a block number. It has something called a Coinbase. We have to figure out what that is. There's a timestamp. There's another piece of information. It's called the Merkle root. And then there is another piece, which is the nonce. And then in the main part, follow all the transactions that are then signed. Now, the structure of the blockchain itself is as follows. And this is the important part, is that each block has a link to the past block. Meaning that so the important part there is that they're intrinsically linked and cannot easily be broken up. Now, so there's a lot of transactions that we want to discuss in this set of slides. So there's a transaction which is digitally signed. We have to have a little bit of a discussion of the digital signature and the process of how that works. These transactions are associated with addresses, so we want to understand how these addresses come about and what they mean. And then you also want to know, how does the linking of blocks work? Why do we do this? We want to discuss what the Coinbase is. How, does that relate to where does it relate to? What is a Merkle root and what is a nonce? Just as a quick preview, the Coinbase does not relate to the firm Coinbase, which is a cryptocurrency exchange.